Imagine for a moment you're looking at a garden hose from 100 yards away. To you, it seems like a one-dimensional line, right? But if you get closer, you'll discover it actually has width, height, depth, dimensions that were invisible from afar. Now tell me, what if I told you that exactly the same thing could be happening with our universe? What if entire dimensions were hidden right under our noses, invisible not due to distance, but because they're too tiny, or operate in ways our senses simply can't grasp? Today, we're re-diving deep into one of the most revolutionary ideas in modern physics, the possibility that our universe has far more dimensions than the four we know: length, width, height, and time. We'll discover how string theory suggests there are up to 11 different dimensions, how scientists are trying to detect these hidden dimensions, using some of the most sophisticated equipment ever built by humanity, and why this discovery could completely change our understanding of reality. Get ready, because by the end of this video, you'll understand why some physicists believe we're literally surrounded by parallel universes that exist just a millimeter away from us. Hey there, cosmic explorers. Welcome back to Cosmic Frontiers, where we turn the universe's biggest mysteries into fascinating discoveries everyone can grasp. We're on an incredible journey towards our first 1,000 explorers, and every single one of you is essential on this adventure of unraveling the cosmos' secrets. Let's kick off our exploration by understanding what dimensions actually are. When we say we live in a three-dimensional world, we're talking about the three directions we can move: forward and backward, left and right, up and down. Einstein showed us that time is the fourth dimension, creating what we call four-dimensional space-time. But here's the question that has puzzled physicists for decades. Why do we stop at 4? Is there some fundamental law of the universe that limits reality to just these dimensions? Think of an ant walking on a strand of hair. To the ant, the world seems one-dimensional. It can only go forward or backward along the strand. But we know the hair has width, and that an entire three-dimensional universe exists around it. The ant simply lacks the necessary perspective to perceive these extra dimensions. According to some physicists, we might be like that ant, trapped in our limited perception while entire dimensions exist just beyond our grasp. String theory emerged in the 1960s as a bold attempt to unify all the fundamental forces of nature. Imagine that everything in the universe, every electron, every photon, every particle that exists, isn't tiny spheres as we usually picture them, but rather incredibly minuscule, vibrating strings. It would be as if reality were a gigantic symphony, where each different note corresponds to a different particle. An electron would be a string vibrating in a specific way. A proton would be the same string vibrating differently. But here's the fascinating detail. For the math of string theory to work, for it to truly explain all the forces and particles we observe, the universe needs to have exactly 11 dimensions, not 10, not 12, 11. This means that beyond our 4 familiar dimensions, there would be 7 additional dimensions that we somehow can't directly perceive. Lisa Randall, one of Harvard's most brilliant physicists, proposed a revolutionary idea. What if these extra dimensions weren't tiny as many thought, but simply curled up in a way that makes them invisible to us? Imagine a piece of paper representing our three-dimensional universe, floating inside a gigantic room that represents a higher dimension. We'd be stuck on this piece of paper, unable to leave it, while forces and influences from the larger room would affect our reality in ways we can barely comprehend. But how is this possible? How can entire dimensions be hidden right next to us? The answer might lie in the very fabric of space-time itself. Imagine you're looking at the surface of a perfectly calm lake from a very high altitude. The surface appears completely smooth and two-dimensional. But if you descended and observed more closely, you'd discover waves, eddies, small variations that create a three-dimensional complexity that was invisible from afar. Space-time might function similarly, smooth and four-dimensional on large scales, but with folds and extra dimensions on microscopic scales. One of the most intriguing proposals is that gravity, the weakest of the 4 fundamental forces, might actually leak into these extra dimensions. This would explain why gravity is trillions upon trillions upon trillions of times weaker than the electromagnetic force. It's not that gravity is inherently weak, it's that most of its strength is spreading out into dimensions we can't access. Now you might be asking yourselves, if these dimensions really exist, how do scientists plan to detect them? This is where the story gets truly exciting. At CERN, the world's largest particle physics laboratory, Scientists are literally trying to create evidence of extra dimensions by colliding protons at near light speeds. When these collisions happen, they release a fantastic amount of energy in a minuscule space. If extra dimensions exist, part of this energy should escape into those dimensions, disappearing from our observable universe. It would be like you're throwing a ball against a wall, and suddenly it just vanishes into thin air. CERN's detectors are looking for exactly that, energy that should be there, but mysteriously disappears. Another fascinating method involves the creation of mini black holes. According to some versions of string theory, if extra dimensions exist close to our universe, it should be possible to create microscopic black holes in particle accelerators. These black holes would be completely safe. They de-evaporate instantly due to Hawking radiation, but their very existence would prove that dimensions beyond those we know exist. Researchers are also testing the law of gravity at extremely small scales. Newton taught us that gravitational force decreases with the square of the distance. But if extra dimensions exist, this law should behave differently when we measure gravitational forces at scales smaller than the size of these extra dimensions. It's like we're retesting if reality functions differently when we look through a powerful enough magnifying glass. Nate Arkenheimt, from the Institute for Advanced Study in Princeton, proposed experiments using microscopic pendulums and incredibly sensitive force detectors to measure minuscule variations in gravity. If gravity behaves unexpectedly at these scales, that could be our first direct evidence that extra dimensions truly exist. But what would these discoveries mean for our understanding of the universe? If extra dimensions are confirmed, it wouldn't just change physics, it would change our fundamental perspective on reality. It could mean that parallel universes aren't science fiction, but rather physical realities separated from us by distances smaller than the width of an atom. Some theories suggest that these extra dimensions could explain cosmic mysteries that have puzzled us for decades. Dark matter, which makes up 27% of the universe but we've never been able to directly detect, could actually be ordinary matter existing primarily in these extra dimensions, influencing our universe only gravitationally. It would be as if a shadow universe existed, parallel to ours, populated by planets, stars, and perhaps even life we could never see, but whose gravitational effects shape the structure of our cosmos. Dark energy, the mysterious force accelerating the universe's expansion, could also find an explanation in these extra dimensions. Perhaps dark energy isn't an intrinsic property of our spacetime, but rather an influence from higher dimensions that are literally pulling our universe outward. Brian Greene, one of the most eloquent popularizers of string theory, described an even more stunning possibility. If extra dimensions exist and extend beyond our visible universe, that would mean other regions of the cosmos, other universes could exist in these higher dimensions. We'd be living in something like a three-dimensional bubble floating in an ocean of higher dimensions, with other universe bubbles scattered around us. But it's important to remember that despite all this fascinating speculation, we still don't have definitive evidence that extra dimensions exist. Science teaches us to maintain a delicate balance between an open mind and healthy skepticism. According to our current understanding, these ideas remain elegant and mathematically consistent theories, but ones that are still awaiting experimental confirmation. Some critics argue that string theory, despite being mathematically beautiful, might be unfalsifiable in principle. If extra dimensions are too tiny or curled up in ways that make them permanently inaccessible to experimentation, how can we ever prove or disprove their existence? It's a profound question that touches on the very nature of what constitutes valid science. However, the history of physics is full of ideas that seemed impossible to test when first proposed. Einstein predicted the existence of gravitational waves in 1915, but they were only directly detected in 2015, 100 years later. Subatomic particles were proposed decades before we could observe them. Patience and persistence are essential virtues in scientific exploration. The experiments continue. New particle accelerators are being planned with even greater energies than the LHC. Increasingly sensitive gravitational wave detectors might eventually pick up signals from extra dimensions. Future space telescopes might observe cosmic phenomena that only make sense if additional dimensions exist. Meanwhile, theorists continue refining models, seeking testable predictions that can distinguish between universes with and without extra dimensions. It's a job that demands a rare combination of mathematical creativity, scientific rigor, and humility in the face of the immense unknown. So, to recap our journey today, we explored how entire dimensions might be hidden right next to us, invisible not due to distance, but because of how space-time itself might be structured. We discovered how string theory suggests reality has 11 dimensions, and how this could explain everything from gravity's relative weakness to the mysteries of dark matter and dark energy. And we saw how scientists are using some of the most sophisticated machines ever built by humanity to try and detect signs of these hidden dimensions. But beyond all the mathematical and experimental complexity, there's something deeply touching about this quest. We are literally trying to expand our perception of reality, to discover if there are fundamental aspects of the universe that remain completely hidden from common human experience. It's a quest that connects us both with our most ancestral curiosity and our most advanced technological ambitions. Think about it. If extra dimensions truly exist, it means that at this very moment as you watch this video, there might be entire universes just a millimeter away, populated by realities we may never visit, but that subtly influence every aspect of our existence. It's a possibility that makes us question everything we thought we knew about the limits of reality. This leads me to a cosmic reflection I want to share with you. Ever since humans began looking at the stars, we've repeatedly discovered that the universe is far vaster, stranger, and more wondrous than we ever imagined. We found that Earth isn't the center of the solar system, that the solar system isn't the center of the galaxy, that our galaxy is just one among trillions in the observable universe. Each discovery expanded our horizons in ways our ancestors couldn't have dreamed of. The possibility of extra dimensions potentially represents the next great expansion of perspective. If confirmed, it would be a discovery that would change not only our scientific understanding, but our very conception of what it means to exist. We would be forced to recognize that even our most basic experience of reality, our perception that we live in 3 spatial dimensions, might be just a tiny slice of something immensely larger. Cosmic explorers. This makes me think about our shared journey of discovery. Every single one of you watching this video is part of a millennial tradition of human curiosity, the same force that led our ancestors to map the oceans, and that today leads us to map dimensions that might exist beyond direct perception. Now, I want to hear from you. If extra dimensions truly exist, and if we could someday access them, what do you think we'd find there? Would it be a realm of completely different physics, where the laws we know don't apply? Could there be life forms based on physical principles we can't even imagine? Leave your theories and reflections in the comments. I love seeing how our community thinks about these cosmic mysteries. And since we're talking about expanding horizons, cosmic explorers, what mystery of the universe do you want me to talk about in the next video? Are you curious about wormholes and time travel? Do you want to understand how supermassive black holes work? Or perhaps you'd prefer to explore the possibility of life on other planets? Leave your suggestions in the comments. You are the navigators of this cosmic journey. We're on an incredible journey toward our first 1,000 cosmic explorers, and every single one of you is essential on this adventure. If this video expanded your horizons on the universe's hidden possibilities, join our crew by clicking subscribe. Like this video if it made you question the very nature of reality, and share it with someone else who also loves discovering that the universe is even more mysterious than it seems. In the next video, we're going to explore another phenomenon that challenges our understanding of reality: black holes and how they might be portals to other dimensions. Until then, keep looking at the stars and remember, the universe is always more incredible than we can imagine, and sometimes the biggest discoveries are hidden right under our noses, or in this case, right next to our familiar dimensions.